Good morning, everyone. Banerjee. I'm a PhD candidate in electrical and computer engineering at Old Dominion University. I'm working in a bioelectronics lab under the supervision of Professor Gymama Slaughter. My research topic for my presentation is gold and silver oxide conducting nanocomposite cathode for glucose biofuel cell. My motivation for this research was based on advancement in medicine and biomedical devices using the nanostructures. It is also applicable in the field of diagnostics and analytical tools such as sensors and fuel cells. Applications like biofuel cells that can be used as an alternative power source for implantable devices or glucometers or pacemakers. One other capabilities of biofuel cell is that it can also be used for glucose sensing, which can be used in wearable and implantable devices. Biofuel cell is a form of a green energy generator. The process involves fuel getting oxidized with electrons released in electrolyte, which travels through an external circuit to cathode producing electricity. Here it shows the non-enzymatic biofuel cell mechanism that oxidizes glucose to gluconic acid at anode. For our proposed biofuel cell configuration, which is done using a substrate of gold conductive printed electrode on bacterial nanocellulose. As shown in the diagram, cathode is modified with silver oxide and gold nanoparticles. For anode, a colloidal platinum electrode was designed using electrode deposition. For silver oxide nanoparticles, we use PEG, polyethylene glycol, continuous heating and stirring to remove the PEG. We used filter, we added silver nitrate, and then we adjusted the pH using the sodium hydroxide, and we got a resultant silver oxide nanoparticle solution in a dark brown color manner. With the gold nanoparticles, we started with gold chloride trihydrate, then eventually we added sodium citrate and sodium bromide, and to see a yellow to wine red color change. To analyze this, we started with UV spectroscopy, in which for the A figure we were able to see for the silver oxide 240 nanometer peak. For B gold nanoparticles, we were able to see 530 nanometer peak, and for the combination of both, we were able to see the peak between 340 to 600, which is due to the attachment of the two particles to generate an absorption spectrum common to that of a single rod particle. This shows the cyclic voltammetry of the cathode, which is apparent that the reduction current increases in the presence of oxygen with an onset potential of 231 millivolt. This analysis is done using the impedance spectroscopy, in which figure A and B shows the performance of anode with the increase in the concentration of glucose and the decrease in the resistance. And in the figure C and D, the comparison between silver oxide nanoparticles electrode and the combination of both of the electrode show the increase in the phase angle and the higher impedance, which were observed in 5 millimole of potassium ferricyanide solution. By combining anode and cathode, we were able to see the performance of the biofuel cell. We carried out using the linear sweep voltammetry, which resulted in a linear range of 1 to 30 millimole. This shows the calibration curve of 0.968 with a sensitivity of 0.778. So our conclusion is that we were able to make a biofuel cell combining of two nanoparticle structures. We did an analysis using UV spectroscopy and cyclic voltammetry, and also we got a biofuel range of 1 to 30 millimole of glucose range. Thank you.